Alright. A. Overhearing all of your conversations as to how you are spending your evenings makes me really worried for your mental health. Take care of yourselves. Stop that. B. I followed my own advice. I have not graded your quizzes because I left everything here and I said screw it. It was great. C. Because we took a quiz, no daily quiz, no homework check, no nothing like that. Game on. How are we? Who? What? Okay. I have a feeling you might do something semi-responsible. This crew decides to stay up until 1, 3 in the morning doing the work that they could have done at any point in the previous 48 hours.
Oh, no, I was doing on the way there, so.
You know, I used to be able to do that, but then, like, the older I got, the motion sickness thing started happening. Have, like, a headache after it. Yeah. All right. Today, like, we finished 3-4, right? I started thinking about that after the fact. Was there an example or two we didn't do?
Yeah.
Let me see.
We didn't do example 8.
Was logarithmic equations. Oh, gotcha. It was just the model. Okay. So, just super quick. Exponential rate. Okay. So it was just a different way to do. It was just a different way to do these. It says blah 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 increasing at an exponential rate. Don't you know the starting amount? And you know how much time has passed? So if I go to that, n is n sub 0 oect. Yeah, back to the example 8. I'm just showing you there's a different way. You don't have to fill it in. I'm just showing you there's a different way. I can say that 2,000 is 125, my initial amount, e to the k, and for t, if you're going to go by months, you just denote that. You say t is time in months. So January, February, March, April, it's been 3 months. Could you solve that equation now? That's what I'm saying, to find k. Right? You would divide ln both sides, divide by 3. Now you know k. Once you know k, you have your model and you can use it to go find stuff. It's just, before I would have to put this in y1 and this in y2 and find the intersection. Like, that's how we did it literally at the beginning of last week. The very last example was, oh hey, now that you know how to solve things by logs, isn't this faster to just divide ln, divide by 3? Ba-da-ba-ba, done. You don't have to mess with the window to find where the intersection is. So that's all it was. And it's just an application of it showing you that now we know how to solve by logs. That's what your calculator is doing when it finds the intersection. Okay? In fact, you can solve every single equation you could possibly think of by putting the right side in y1 and the left side in y2 and finding the intersection. That's why we don't show that to freshmen. Because otherwise, it's bad enough just with Slater and photomath. If you showed them that the device in the classroom does it for them. Oops. So, yeah, we just missed that last example. Don't worry about it. Just cross out, whatever. So we move into modeling with nonlinear regression, which was the other way that we learned it. If I tell you that something is increasing at an exponential rate and you got a table, we know how to stat, calculate regression. We've gone through all the different types of regression. Only difference is right now, we're going to have exponential, but we're also going to have power, but we're also going to have logarithmic, and we're also going to get a new one called logistic. They're all just different types of nonlinear regression. You just got to find the one that fits your data. So, example, Mesa, Arizona, one of the fastest growing towns in the United States. Y'all know why?
Old people.
Old people. Legit. I'm from North Dakota originally. I moved to Arizona. While driving in Arizona with still having North Dakota plates on my truck, people left like a 3-car bubble around me on the freeway. Because they know that people from North Dakota, South Dakota, and Minnesota are probably old and don't know how to drive in a city. So they're going to crash. I kept those plates on my truck as long as possible because people just leave me alone. It was like having a force field. It was great. But yes, Mesa, Arizona. Mesa, Tempe. Tempe is a big one. That's like Moneytown. Like there's a lot of towns in Arizona are a bunch of old, privileged white Norwegians who have now retired, and they will move to Arizona in the winter because it's warmer. Like, yeah. That's why it's one of the fastest growing cities, because people are getting older. So old people go there because it's warm, and they say, screw this, I don't want to be cold. So, or Florida. But every headline of what the that you can think of usually begins with a Florida man. So Florida's got wow. So anyway, I got a bunch of data. What should I do with data?
Stat plot.
Stat, edit, dump in. Before I go dumping this stuff in there, I need to say X is years since what? I can use 1900. I can use that as my 0, right? Okay. Now that's going to be important when I say X is years since meh, or months since meh, or hours since meh. Whenever I state that, it is going to be important today. Because remember, I can't take the log of a non-positive. So when I get to logarithmic regression, this is going to matter. Because I can't take the log of 0. I can't have 0 as my input. So we just got to keep that in mind. In this case, it's exponential model, so go right ahead. Dump all that stuff in. Womp. Bigger. Oh, well, whatever. I can see it. Stat, edit, dump stuff in. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and a hondo. Okay, with 0.7, 1.6, 3, 3.7, 7.2, right? Super blurry up there. If I'm doing any of them wrong, you can stop me. 18.8, 16.8, 33.8, 63, 152, and you see the exponential takeoff here, 289 and 396. 288. Okay. Feel like that meme of the gal like, huh? Squinting at someone. Okay. Big. So I've got all stuff in, and it specifically says exponential regression. Okay. So if it's specifically saying exponential regression, how do I find my exponential model of this thing? Stat, calculate. And we've got all this stuff, right? You want to be careful that you're using exponential, not power, not logarithmic, not logistic. Like, use the right one. Also, before I even do the regression, how do I get my stat plot? The table that I just had, how do I get my scatter plot for it? Okay. Plot one on, make sure that is actually a scatter plot, and then I go to graph, and meh. Okay, I can manually change this. I can go to my window. Oh, just realized we still have a quartic in there, or a cubic. I can go to my window and manually say I'm going to go from 0 is 1900 out to, I'm going to go further than just the year 2000. So, I don't know, 150? I'm not going to go by ones. Maybe I'll go by tens. Whys? Well, we know that the population was never negative. Y maximum? It went up to, what, almost 400 just in the table? And it's exponential, so if I'm going out to 150, it's going to be much larger than that. 500? Okay. So I can manually change my window like this. What was the cheater way to get there? Zoom stat. Remember that zoom stat only works if your stat plot is on and if you have data in the table that is plotable. Okay? So, why do we have people gone today? Wait, 1, 2. I know that one. 3. So, okay. So we got that. I will stat, calculate, exponential regression. Make sure it's your correct lists. Store on a 84. We got that cute little shortcut, alpha trace.
Yeah, there isn't that option inside TI-84.
At TI-84 plus and higher, the alpha shortcuts showed up. So if not, how do I still do it? What if I don't have the alpha shortcuts? How do I get that there? The variables, the y's, the function. Okay? So you can still do all that. No. We've done this so many times in class, but I'm not going to, no. Calculate, write down whatever it was. So I'll say it's about 0.69 times 1.067 to the x. Approximately. And I will use approximately for my model. Like little squiggles. Now, if I graph it, that should... See, it's not perfect. What do I get? Who, what? Okay, you still have the correlation coefficients on there from the last time we did this. This does not tell me how good of a fit it is. If I go to my mode, I can turn stat diagnostics on. Or alternatively, if I'm way back at the main screen, I can go to my catalog, say you don't have the alpha shortcuts, down to the D's, and I can turn diagnostic on. Okay, so however you're going to do it, once I have that, that calculate regression is going to have a new feature after I'm finished. It's going to tell me how good of a fit is my model. 99 and change percent. We're always using R squared. That's a really good model. Now, models are going to look really, really good when you're talking about interpolation. We kind of talked about this before. Remember the difference between interpolate and extrapolate? Within the data or outside the data. Okay, and once you go outside the data, things start getting kind of funky because exponential functions will take off fast. And it might not quite meet the pattern you're seeing. So, use your model to estimate the population of Mesa in 2020. Boy, they didn't expect that something would kill off half of them. So now that I have this, no, but still over 750,000 dead, and most of them are either over 65 or disabled.
Is that in just Arizona?
That's our nation. Over 750,000 dead.
So if it was just Arizona, I'd be like, oh.
I thought you were saying just Arizona. Like
No. But Arizona does have a very high population of conservative white old people. So those people are, by the numbers, going to have a higher death rate. So, anyway, once I have this, it says in the year 2020, what's going to happen? I can just jam in 120 for X now that I have my model. Option 2, since my graph went out far enough, I could just trace out to 120 years. Be careful right now, look at where it's tracing. It's tracing the stat plot. If I try to say 120 right now, it's going to quit on me. Gone. Because that's the next option, and I'm getting to it. Okay, trace, I have to arrow down to say that I'm actually on the graph, then go out 120 years. And I can go to my table settings, switch my independent over to ask, and now I can go to my table and I can just ask it whatever I feel like because I have the model. I can say in the year 2020. Now remember, if you put 1675.9 as your answer, you are wrong. Because look at the data, look at the table, what are the labels? I'm pretty sure there's not 1,600 people in Mesa. Okay, 1.6 million. So if I kept going out and I said in the year 2050, now we're out to 11.7 million. Okay. COVID did. Yeah. Oh. Yeah. And that's when we're going to start talking about logistic, because the further you go out, this doesn't make sense, right? Say most of you are 16-ish, 17, okay? What happens if we go out to your retirement? 50 years from now, what happens if I go out to 171? You can tell me we went from about 1.6 million to 46 million just in Mesa.
That feels like
Right? And that's what happens with an exponential model. At a certain point, the exponential model starts getting into the realm of unreasonable. So, y'all took biology. You know what homeostasis is. Okay. Homeostasis is any natural system's tendency to maintain balance. If there's too many rabbits, here come the predators. They're going to eat the rabbits. Once the rabbits are dead, there's not enough food supply for the predators. The predators will move on or die off. Think about the grasshoppers the last 2 summers. How many of you walked out into your lawn and were attacked by a swarm, by a plague?
Mountain biking.
Okay. Just nicely zipping down the trail. Yeah. So, right? I thought it was funny because bikers. So, y'all remember how to press the buttons? Just cross out the bottom one. You remember how to press the buttons. Okay. The only thing that I would like to try is logarithmic. Okay, that's brand new. Logarithmic regression for a new table about twin births. So, what's new about this, I can't put in years since 1995. Because if I call this 0, what happens? What's the log of 0? Non-positive. We break the third commandment of domain. So I'm not allowed to do that. I have to be careful in how I set up my data. Additionally, what base should I be using? Should I use common log? Should I use base 10? Should I use base 2 just because it says twin births and I feel facetious? Not whatever I feel like. This is number of twin births in the United States. The ratio of Y chromosomes is lower in this room than in other classes. Ladies, I want you to think ahead to the future when this is not just Pop-Tarts and Mountain Dew.
No, that's not.
Do we just collect this data every year? Like on April 13th, we will collect our data and say, oh, no, hold on, ma'am, you need to hold that in for another couple months. It is not data collection day yet. Okay, now you can have your twins. It doesn't work that way. I'm pretty sure kids are born continuously. Yes. Okay. And I'll tell you right now, by that third trimester, you're just going to be screaming like it's an alien parasite. Get it out! Literally, there are so many things that they don't tell you because public education. There are so many things that you don't know. Like, y'all know Aliens, like the movie Aliens? The big long like skull thing and the right? Do you know that the way that the uterus is shaped, if you bend back like that, you can see like a little alien head right there on your gut? Huh? Oh, I could keep going. There were no boundaries in my household. So, now that I've terrified a few people, and just, ew, future biology. I need to dump all of this into my table again. We need to have something reasonable for our year. I don't want to say 1995. I probably don't want to go all the way back to 1900 because look at my data. 1990? Sound reasonable? Okay. So go ahead and dump all of this in And let's go. So we're going to go stat. Oh, y'all know that when you hit stat, one of your options is clear the lists. So you don't have to like actually go up and clear the lists out. Also, if I go stat edit, if I highlight the list and just hit clear enter, it'll clear the list. Do not hit delete. We've been through this before. It'll just straight up delete the lists. Holden found the way to bring it back. I don't remember what it was. Okay. You can completely reset it. Yes. I'm showing you there's options where you don't have to get rid of everything on your calculator just to clear the list. So we're going to say 5, 7, 8, 10, 12, 14, and 15. Okay. With 96, 736. 104, 137. 110, 670. 118, 916. 125, 134. 132, 219. 133, 122. Oh, I got too many numbers. Oh, okay. So 5, 7, 8, enter. 10, enter. 12, enter. 14. There we go. All right, check my numbers, make sure nothing dumb. So, since these births are happening continuously, when I go to do logarithmic regression, stat, calculate, I should probably do not choose logistic. Logistic is not logarithmic. Just because it has log at the beginning of it means nothing. LN, natural log regression, because this is something that is happening continuously. Natural log, base E, continuous. Okay. And we'll use our list 1, list 2. We'll store it. 1. Calculate. Ba-dum-bum-bum. That's a really good fit. 98.97 change. It's a very good fit. So 38,428 and change plus 35,000 and change ln of x. It just changes the a and the b, meaning the coefficient of your logarithm and your vertical shift. Okay, so you write down your model. Once you got your model, if I go back to zoom, I still have my stat plot on. So if I zoom to my stats, shoop, there we go. Stat plot.
Actually, zoom stat. Oh wait, I need to turn on stat plot.
Another reason to not reset the entire calculator. Turns out when you just yeet everything out the window, you kind of have to reinvent the wheel. So, I have my model. We wrote it down. I checked my graph. Yep, that's got that logarithmic curve to it. Now I get to answer the questions. Use your model to predict when the number of twin births, so the y value, will reach 150,000. So I have a choice of actually going 150,000 is, what was that? Trace. 38,428.963 plus, was it 35,000.196? 1609. 179. There we go. 1679, so 168. ln of x. If I wrote it down like that, couldn't I subtract, divide e to the? Like to solve my equation. So I could do it that way. Option 2, since I'm already here in my calculator, could I go to y2, dump in 150,000. Oh yeah, that's higher up. Window. I need my y's to go at least that far. My x's. Well, no, it literally doesn't like zeros. That's why when I was putting in my data, it called 10 1. Like it just doesn't like zeros. The emulator, it's been that way forever. Years probably further than that. I don't know. I'm going with 30. Did I still miss another zero? Ah, that's better. So I can solve it algebraically, or I can go find my intersection. Second, calculate my intersection somewhere between this guy and that guy, and screw you, tell me the answer. And it says in 24-ish years. Keep in mind, at the very beginning of this, did you write that down? Did you say X is years since 1990? If you don't write that, your model is literally meaningless because I have no idea how you got it. You have to write the label for your X's if you are changing it in any way, shape, or form. So 24 years since then, 2014, yay, got lots of twins. So, blah, blah, blah. Use natural log regression. Okay, just make sure you have a note to yourself. Don't say logistic if it's saying logarithmic. Those are not the same thing. You choose LN reg, natural log regression, because things in the real world happen continuously. You can't just tell her, I want you to hold on to that for another 3 weeks. Okay?
Just log when it's in like business or something like that.
Anything that happens continuously. Yes. Yep. All right. So, logistic is its own thing. Now, there's a proof for how this form is derived. We ain't going to go through it. Instead, just want you to see it. We're just kind of talking about that whole homeostasis thing. The idea is things can grow exponentially, but there's a certain limit to it. It can't just go forever, right? Think about the grasshoppers that came the last 2 summers. Right? Right about midsummer, as everything dried off, all of a sudden, plague of grasshoppers. If you were paying attention from the previous year, did you see the tiny little ones hanging out in your yard? Just a bunch of itty-bitty little bugs. That was the horde gathering its army. Things can increase exponentially, but the number of grasshoppers couldn't increase exponentially and just keep going exponential all summer. Because eventually they reach a point at which there's just not enough resources for them. So they kind of flatten off. Okay. Now, there's environmental factors that, like the spiders. Sorry, thank you. I live on old ranch land outside of Bell. Lots of spiders, like 50 different varieties. And 2-3 years ago, it was not uncommon for me to, severe phobia. It was not uncommon to have the yellow and black house spider, to have the wolf spider, to have black widows up on the top of the hill, to have like the little black ninja jumper ones. Like, we had all the different varieties, and they were starting to come in towards the house. We were getting some really gross webs up in the eaves. We had to have professional exterminators come in because bug bombs weren't doing it. The last 2 years, no spiders anywhere near the house. Because they have friggin' Pizza Ranch buffet out in the yard. They got everything they need out there. Okay? The grasshoppers, they're just gobbling them up. Now, that means there's going to be 5 times as many of them when the grasshoppers are gone. But, that explosion in population reaches a limit in which, no more spiders, in which either natural predators or resource depletion caps the population. How many movies have you watched where that's like the dystopian future, that humans have run out of resources and we have to go colonize other planets? Or we have to leave all the garbage here and go float around and become 700 years of fat people. That's Wall-E, right? Like, there's this natural limit where things can grow exponentially, but at a certain point, you just can't go any further because there is a natural limit to the resources. Remember, natural limit? E was the number that was a natural limit of a continuous growing function. So what happens is, blah, blah, blah math wizardry, they come up with, if I rearrange this continuously growing thing to have a reflective property of exponential growth and decay, I get what's called logistic model. You notice it's still got that E in there. It's still got that natural growth in there. Logistic model is used when something grows exponentially, but you know it can't go forever. Like all the grasshoppers. Like bacteria colonies. You've done the Petri dish thing in some class? Like you go get the Q-tip and you swipe the doorknobs and the toilet seat and your phone, and then you grow them. There's only so much growth medium in that Petri dish. So the colonies will explode exponentially, but at a certain point they run out of resources and they flatline. That's logistic growth. Okay? Before we actually start typing stuff in the calculator, I have to front load you on this. Logistic growth, because of the way that this model is made, the way it's calculated, your calculator will take time to do this. You remember how Frank was at the beginning of the year, me trying to even do linear regression? That's how your calculator is going to be with logistic. You got to just give it time, let it think. If you see the little, if you try calculating and you see the little yellow circle in the corner, or no, it's a blue on yours, right? I don't know. It's yellow? Okay.
It's yellow blue on yours.
You see the little yellow circle, it is thinking, leave it alone. Don't know. I want you to... The next time that you're taking a test, in the middle of your test, I'm going to come over you and just start poking you. Faster. Faster. More. No, faster. And just keep... Are you going to be able to think very well? What's going to happen eventually, if you poke too many buttons, you get the white circle of death. You have now frozen your calculator. Congratulations. You do not have to restart the whole thing. Second off. Just turn it off and then back on again, just like customer service tells you. Okay? Just like Chad from Milwaukee, who has an incredibly thick, like, Bangladesh accent. Like, okay, Chad. Okay. So, just when we do this, when you hit calculate, just let it think. All right? Just let it think. Don't press buttons. Don't poke it repeatedly, because you will break it. Oh, also, read this part again, because it's super important. The very last line. C is the limit to the growth. Meaning, whatever C is, whatever the numerator is when you get your logistic model, it will never go past that. So let's say I'm doing a logistic model and C is 70. And I ask, when will this surpass 80,000 votes? It can't, because 70 is actually the limit to it. It will never surpass that. Okay, so this, I would like highlight that or underline that or something, just so we don't miss that important fact for our models later. Okay, so here we go. Use logistic regression to find logistic growth function to model the data. We're talking about, see, they didn't even try to get fancy and use real world context. They're literally just talking about yeast cultures. Okay, like I am in a lab and I'm doing the stuff. Okay, start typing. Dump all your data in. All right, stat, edit. 1, 2, 3, 4. $60, is that 8 or 3? Okay, no answer. 68, okay. It's what?
Shortcut to type instead of typing 1 through 18. Is there like an equation you can put in?
Yes, but it'll auto-populate all the way down through the list, and then you'll have things in list 1 that don't match with list 2, and it won't be able to do the regression. You can also do it with a summation formula, but we don't know that yet. You're supposed to have the fastest thumbs of any generation. I thought you'd be fine with this. I'm way faster if I have the physical calculator in my hands. Nine, 641, 653, 654. What? Why am I so far down there? Because I started at the bottom. Okay, hold on. Delete, 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 delete. Okay, whew. All right. So got all my stuff. And you should even notice in the table how it starts trailing off at the end. Everyone got data? Good? I'm going to come back here. Clear. Clear. Now, right now I have no model in there. I cleared out my Y1, Y2. I only have my data. My stat plot is still on. So I'm going to zoom stats. You see the logistic model, right? Increases exponentially and then trails off at a limit. When I see that S shape to it, I will stat calculate a logistic model. I will store it in Y1 and time it. 2, 3, 5, 8, 9.
Minus, oh, I got 4
Imagine this with Frank's X, with the new computers. This would have taken the rest of class.
Mine's finished.
Yeah, mine's good.
Like, it takes a while. You gotta just bear with it, let it think. There we go. So I had almost 40 seconds, which is not long. Y'all would have died in the dial-up era. Okay. Write it out. That is y is approximately 661,565 over 131, missed my 1 plus 131.178 e to the negative, whatever b is, 0.555 x. Okay. So logistic it's just a model you're going to use when it doesn't make sense for this thing to continue going exponentially. I don't know about that, kid. Okay, so now if I go to my graph, I already had my stat plot. I should now have my logistic model on there. Pay attention to the top, it said 661 and change, right? Was my C. So based off of my model, if I asked, when will I have when will I have 670 different yeast colonies in my culture? Never. It's not going to happen. Like, they will literally run out of space and resources. Okay? So, again, I don't feel the need to do this. Y'all know how to press buttons. As long as you wrote down the things like, don't poke it while it's thinking. Just make sure that you don't do that. You flip over to the next page. Here's why we have to know all these. And this is why I wasn't too keen on doing a bunch of extra practice. Is we have now done linear, quadratic, cubic, quartic, logistic, logarithmic, exponential, and power regression. I should now be able to give you any data set, and you can now press the buttons, look at your scatter plot, determine which is the most reasonable models to apply those models, find their correlation coefficients, and tell me which one makes the most sense. You should be able to go from table to reasonable model to answer without having any clue what type of function it is, because now you have done all the work. You know what, like, this is just a tool to help you decide. Example. The data are the little boxes on there, just like when we do our stat plot. That line, that is not a fit, and that is not even close. The correlation coefficient on it is 0.74. You really want to see Big Bubba John walking through Walmart with only 0.74 clothing coverage? Okay? where he's still rocking his old high school football T-shirt, but it's got like his hairy gut hanging out the bottom, and got like the butt crack sweatpants and stuff. Like, you don't want to see that. Walmart is scary. Okay. Have you ever seen the calendar, People of Walmart? We used to get that for my grandpa every year.
Oh.
It's a calendar called People of Walmart. And every picture is just candid pictures taken of people at Walmart, and oh boy. Quadratic, even though 94% fit, I mean, that's pretty good. It's not amazing, but then you go and look at it. You're like, that's not even close. Then I go and look at power regression. I'm like, okay, that's not bad. I look at exponential regression. I'm like, that is almost perfect. Clearly, it's not logarithmic because it's not even going in the right direction. So out of the 6 up here, I would say power, exponential, and logistic. Another note to make, logistic will never have a correlation coefficient. Logistic does not have a correlation coefficient because of how it's calculated. You want to find out how it's calculated and mess around with that, go take stats. We're just prepping you for it. Okay? So I've got 3 possible models. I have to go find those models, look at those 2 correlation coefficients. If I had power regression and exponential regression right now, I would just kind of ditch the power regression, right? Because even though they both fit a little bit better, this has a 99% fit. So I'm down to exponential versus logistic. You have to know how the models work. You have to use common sense, logical thought to determine which one is the best. Not just has the best fit. Please tell me you're not Googling people at Walmart.
No, it's not.
Okay.
Why would you need a person?
That's true. So, choose a regression. Travel time and distance. Use the data below to determine a regression that best relates to the distance a seismic wave can travel. Like, I don't know if y'all are South Dakota, born and bred, but how many of you, right? How many of you have actually felt an earthquake?
Scary.
Put away the people of Walmart. Okay.
I'm sorry, shopping cart full of Reese's peanut butter cups.
I mean, I know how I must look walking out with $200 worth of Pop-Tarts. So, Maddie plus people of Walmart is a dangerous combination. You all know that you've been through 8th grade science. You've been through physical science. You understand basic geology. Okay? Earthquake, plates shift or slide or just plain snap. You have something that creates a crap ton of vibration in the ground. It shakes things on the earth that were built above the ground. Okay? And you can feel that wave. It is literally a wave transmitted through a medium. That medium happens to be rock. The density of the rock changes how far it's going to go, changes how well it's transmitted. There's all this other stuff that goes into it. It says time that it has traveled, how far it has traveled. It is very possible that you have an earthquake in Washington State, and we feel it in South Dakota. It might be one of those things where only people who are sensitive to it even feel it. Like, all my senses are cranked up to an 11. Most of you would probably go, huh? I'd say, like, dude, what was that? And you'd just think I was crazy. Like, no, I would have felt the actual wave. Determine how far from the epicenter the wave will be at 8.5 minutes. We talked about interpolation and extrapolation, which is this. Interpolation. So I don't have to worry so much about the tail end of my data because I'm not extrapolating. That's going to be important. Just like before, dump it in. Also, travel time, start at 1. Don't start at 0 because maybe we have to use a logarithmic model. Maybe I have to use a logistic model. I don't want to start at 0. So, now I will, 2nd plus 7, enter 2, because I just want to get rid of everything. Mode, I want to turn my stat diagnostics back on because I know I'll need them. Stat, edit, 1, 2, 5, 7, 10, 12, 13. Wow, you just didn't like that at all. 10, 13. Okay. 400, 800, 2500, 3900, 6250, 8400, 10, 1, 2, 3. That's really crappy to say at 9:15 on a Monday. 2500, 3900, 6250, 8400, 10, 1, 2, 3. Okay, now we got it. So, to find an appropriate model, I got to start with my stat plot to find out what should I even be looking for. Stat plot on, zoom to my stats. Based off of that, what can I throw out? That might be a quadratic, the curve right there. Logarithmic curves the other direction. I can throw out log. What else? Linear, it ain't a line. If I've got all these other curved models, I can definitely throw that out. That's about it. So I'm going to stat, calculate, and we'll just start going. Maybe it's a quadratic. Do you have your stat diagnostics on before we calculate this? Okay. So quadratic regression, I will store that in Y1. Go find some stuff. Okay. So we've got Y1 was 36,623x squared, 264.048x plus 147, just straight up, 99.8% fit. Not too shabby.
Do you want us to store these like Y1 and stuff?
Yes. Because I don't know which one I'm going to choose yet, so I want to just store them all. I understand that on a really pixelated black and white screen, the graph is going to look like trash. It's just going to look like someone punched the screen. Like you ever broke an Etch-a-Sketch? Okay? It's going to look like that by the time we put all these models on there. I'm going to do it again. Stat, calculate. Okay, so I got my quadratic. Quartic isn't going to get me too much extra. We said we could throw out logarithmic. So maybe I'll try exponential. Stored in Y2. Calculate. So Y2 was 483.612 times 1.284-ish to the x, and my R coefficient, 94%. Okay, that's another thing. We don't need to go find all of them right now. Maybe I could just go look at them one by one as I finish them. And you said that just, ew, right? It doesn't, we know it doesn't fit because of the correlation coefficient, but if I just look at it, I know it's probably not reasonable. So do you want to just toss that one right now? Like not even bother with it? You can check them as you go. You don't have to check all the way at the end. Okay, so I'm just gonna yeet that one out of here. Get out of here, go away. Then we'll stat, calculate. What else did we say we were gonna try? Probably power, because it still has that curve to it. We'll do power regression. I can go to Y2 because I just got rid of the other one. Ooh, that one's got some, okay. So now we have 361, 828 times x to the, y'all know the difference between power and exponential, right? Power is x to the thing. Exponential is thing to the x. Okay. 1.251. And that's got a 99.6%. So it's just about as good as that quadratic. Go and take a look at your graph. Not too shabby. And finally, stat calculate. We also want to do logistic. Logistic's going to take a while.
Wouldn't it just be like logistic? Because eventually,
Hold that thought. You were asking the right question. We're going to get the model and compare them and ask why. That's the point of this example. Which one do we choose and why do we choose it? And the answer for this one is going to be different than the next one. Like you are definitely asking the right question. Okay. Wouldn't it just always be logistic? Like logistic is a natural limit to a thing. Do you know anything in the real world that just exponentially goes forever? Money? Okay.
you can go into debt with it, so technically it keeps going.
Is that true? Like, or at a certain point, do people say, all right, we're going too far, and just kind of cutting off? Pay attention to current events. Okay. We just keep printing it, right? We learned nothing from World War II and collapsing economies. Like, but no, legitimately, pay attention to current events right now. I know that you're teenagers and you probably don't listen to NPR religiously like I do, but there has been this big push to get this infrastructure bill through. But there's 2 or 3 holdouts who are centrist. Centrist means I'm not going to push progressive ideas. I'm not going to be alt-right. I'm just going to hang out in the middle here and say, like, look, guys, let's kind of be the middleman. And there's a couple of folks saying, yes, this is all good. We should be doing this. But it's too much. Money does not just go forever. Because at a certain point, people are going to start pumping the brakes and saying, look, that's too much. There's that natural limit to it. We were talking about the yeast cultures. We were talking about, hey, how about twin births? How about I hope. Have you heard about that Nazi scientists went to South America, started experimenting on people, whole bunch of twin births, right? Like they still don't know the complete causality between it, but the number of twin births in this particular region where this crazy scientist went, they had something like 800 times the amount of natural twin births in that area after he was going around inspecting pregnant women. And now all of a sudden there's these twins everywhere. Like it's weird. There's documentaries about it. Go watch it, right? But we just did the twin birth model up here. Can you have twin births explode exponentially like that and then just keep going? Eventually, people can get tired, okay? It's not just going to be twins and twins and twins and twins and twins and twins forever. There's going to be a natural limit because there's only so many human beings there. And after a certain point, you're just like, nah, I ain't doing that again, okay? You can't have this exponential increase forever. So at what point do I say everything is logistic? At what point do I use something that's not logistic? It comes back to, we got our model. Okay. It comes back to what is the question we're asking. Go back to the original problem. Look at the question. What are they asking? Because all of those models look solid until I change my window and I go out further. What happens when I go out 50 years? Okay, to, I don't know, what's that, 11,000? Say I go out to 100,000. Okay, down there where my data set is, all of these models, they're all about the same. But look at that explosion of difference. At what point do we stop saying everything is logistic because everything has a natural limit? And we say, no, I'm going to use this one. They asked us, how far from the epicenter will the wave be felt 8.5 minutes after? Look at your data. Interpolation or extrapolation? Extrapolation. It's interpolation. It's inside my data set. If I'm inside my data set, we ran across this with polynomials about a month ago. Just use the one that's the best fit. In the case of which one's the best fit, I don't look at the earthquake wave will just continue reverberating around the world until the whole thing shakes to pieces like a 1984 Cutlass Sierra. Okay? Like, it's not just going to shake itself to pieces. There's a limit to it. Well, yeah, but I don't care about the limit because I'm looking way back here and tracing to 8 minutes out. It's right smack in the middle of my data. So if it's right smack in the middle of my data, I'm just going to use whichever one has the best fit. And the best fit is, ironically, the quadratic. Had nothing to do with any of these power and exponential and logarithmic models that we've been doing. Said that's where this has been headed for the last month and a half. Can I give you a table and you do all this work and decide what the appropriate model is? Turns out the appropriate model was a quadratic, like we learned back in Algebra 1. There's never enough time. Not even close. Okay? Show me some thumbs. Can you do the logistic models? Can you put all of the models on there? Okay? It's time consuming, right? The question is, can you determine the appropriate model? I want you to put that big honking note on there. Like big flashing neon sign. If it's interpolation inside my data set, use whatever fits best. If it's outside my data set, extrapolation, now we got to consider what's reasonable and what's not. And I'll level with you. Most of the time, if it's got that exponential curve to it, and you have to extrapolate, logistic is the correct call. Because things don't go forever. Okay?
Still kind of confused on how money could have a limit. Because, especially with like digital currency.
We are the limit.
But
We are the limit. Because at a certain point, we say the inflation is getting too much. You know about the Federal Reserve? They change the interest rates that all of the big banks and companies are using. So then the inflation is going up. They hike up the interest rate. All the companies that are saying do more of this, they slow themselves down. And they say, little too much for my blood. I'm going to back off and be a little more conservative with my financial decisions. As a company that's doing billions and billions of dollars.
we're above that.
They shoot themselves into space because it looks good on social media. We don't say that name around here. Ew. Because he's a trash person? Also trash person.
So bad about Elon.
Lizard man.
He's a horrible person. He violates a lot of human rights. And recently he said, because I'm autistic, which, so what? I'm allowed to be a trash person. And a lot of neurotypical people look at that and think that that's what autism looks like, and it is not. He claims it.
So, wouldn't rocks be forever?
Wouldn't rocks be forever? Are you trying to sell engagement rings? What the? He went to Jared. Like what? Okay, no, Maddie, no, because I know where this is going. Okay, the last no. We are ceasing conversation. No, the last couple of things: linearizing data. All right. There is a formula that you should have seen back in algebra half for how to create the line of best fit. It is not good. It takes this point and 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 this point, and it finds the average of all of them. And then it finds the slope and y-intercept based on the averages of all of the points. It takes forever, but it works. Every single type of regression we just did, they linearize your data, and then they apply that formula. That's why the logistic one takes forever. They linearize the data. To linearize the data, you undo whatever the function is. So for example, when I do quadratic regression, my calculator is taking all of your data and square rooting it to turn them into a line. It finds the line of best fit and then squares it to put it back out to where it should be. If I'm doing an exponential regression, it does the logarithm of all of your data. And then after it gets the linear model, it takes them to that power again to put it back in exponential land. It's something the calculator does. Why would I do it myself? No. Cross out the last 3 slides. No. I'm not going to linearize data. Screw that. My calculator does it for me. Cross that out.
Oh, you're serious.
Yes, I'm serious. Cross those out. Linearizing data is something that you should never, ever, ever, ever have to do manually in a class. No, that is beyond dumb. Cross it out. We don't do that. We don't do that here. Okay? We don't do that here. I just wanted to tell you this is what your calculator is doing. If I'm finding a cubic model, my calculator is doing what the book wants us to do manually now, and it's taking all of your cubic data points and doing the cube root of them to turn them into a line. Does the line of best fit formula with it, and then cubes them again to put them back out in cubic land. We don't have to do that. The calculator's doing it for me. Why would I do that?
Are you gonna have homework then?
Yes, we will. Your assignment is not going to be small. It's not going to be small. Not going to be big. There we go. Words. Like, okay. Words are hard.
I agree.
It's going to be like, honestly, I'll probably just pick one solid problem that says, go find all the models, then pick the right one. It'll probably just be a problem. Okay? I got to double check it, but I'm betting that's your assignment. What I want to talk about, because we do have time, is tomorrow. We start chapter 4. 4 is the big kahuna. 4 is all about trig functions. It is preparing you for the next class. Like, everything that we've done so far has been review Algebra 2 and expand upon it.
How many people here are actually taking trig next semester?
Yeah. Who's doing trig next semester?
I don't know yet. I don't know if I'm gonna drop it.
About half. Honestly, you're gonna just annihilate it if you come out of pre-calc and go straight into trig. Like, easy A. No joke.
What if you don't?
Then take it next year and it'll still be easy. Like, we have the dubious honor in here of trying to prepare you for the next 3 classes. Trig, calc, and stats.
We take stats in high school.
Yeah. Dual credit.
I'm gonna do it next year.
You have to do it dual credit. Someone at BH. Or SDSU.
For dual credits, you have to go through BH or...
No, you can do either one.
Oh, okay. But it has to
I know that we've had kids do dual credit through either one. But we're going to be doing... I know that your geometry experience was insufficient.
Actually, mine...
It is expected that coming into tomorrow, find everything else.
I actually tried to use that to win a game of 8-ball on
Hey,
my
we
phone.
need to find the other degree. Easy.
Yeah.
Find the sides.
Well, we know the
Poster wall.
Is that a right triangle?
Probably not.
None of that works.
It's like the sine of A and the angle of A is like over it.
Law of sines, right?
Sines.
I don't have a control pair right now to start law of sines. Law of cosines. Okay. How about this?
Then have 60, and then you just know that.
How about we do a quick geometry?
Yeah.
X. What's the? Is X 2 to the scalar?
Agreed. Not.
We did go on that.
This is gonna really annoy me.
It was not it. I told us.
Okay.
We're gonna at least
It was
do that.
easy. I just learned it.
Do you remember SOHCAHTOA?
Yeah.
You gotta get a little phlegm in there. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I know that our geometry classes do not cover cosecant, secant, and cotangent. It's just their reciprocals. It's their reciprocals. That's it.
Listen to the song in class.
Cosecant is hypotenuse over opposite. It is the reciprocal of sine. Okay. Additionally, like, you need to know SOHCAHTOA. Do you know Pythagorean theorem? Okay.
Yeah, that's all.
I know. I know how to do all these. I just
You said
get
that
married to beautiful though. Thank you. I don't know. No,
The best part.
okay, yeah, but I started
Like,
it's
like,
yeah,
I
that's
don't
true.
know. And then start singing the quadratic formula.
Yes.
I recognize it, but I do not remember it.
Do you know the side length ratios for a 45, 45, 90 and a 30, 60, 90 triangle?
No.
No, Jeff.
Figure it out.
1,
I will tell you before you come in tomorrow, you should be able to fill out those and that table by memory. When you go on to Trig, you don't get notes for your tests. Everything that we're about to do for the next 3 weeks is based off of this. It is all built off of special right triangles. And if you don't know special right triangles, you are going to have to look things up a lot. I am also, multiple times throughout Chapter 4, going to break my own rule because it is that important. And you are going to get a no notes, everything off your desk, fill this out. This and the unit circle.
What is the unit?
Oh, I took the unit circle down and last year and never put it back up.
Are you gonna do what you did last year and take notes away from us?
That was last year's class because they were academically dishonest.
Oh yeah, I heard about that.
Oh,
That's the unit circle.
Oh, I heard that's actually deep.
It is incredibly easy because it's this on repeat. If you know this, it's that. Repeat but change signs. It is not difficult. But if you don't know this, you're in for a hurtin'. Find a scrap sheet of paper, copy that down. Okay.
That's what I was trying to. I have one too.
If you got to go Quizlet, Kahoot, old school flashcard, you got to know this. Because the next 3 weeks are built on it. I'm not trying to freak you out. I'm saying you should know this already. Sorry. Okay. Now, sine is opposite over hypotenuse.
What is S? Is that SEC?
Secant. We'll get to it tomorrow. We'll tell you when you're older. Okay. It's pretty simple. If I know sine, cosine, and tangent of one angle, I can fill out everything else for both it and its complement. Because the sine of one is the cosine of the other.
3 degree tangent to square root of 3.
I can't talk and write at the same time. Square root of 3 over 3. Close. Opposite over adjacent. 1 over square root of 3. You have to rationalize it. The sine of one is the cosine of the other. The cosine of one is the sine of the other. That's why it's called cosine, because they go together with complements. Add up to 90, 30, and 60. Opposite and adjacent swap. All of that stuff, reciprocal to find cosecant, secant, and cotangent. Reciprocal of a half is 2. Reciprocal square root of 3 over 2 is 2 square root of 3 over 3. Yes, you have to rationalize it. Reciprocal of square root of 3 over 3 is just square root of 3. You have to rationalize and reduce. If you know one set, you can fill out the rest. If you know 3 measures, you can find the other 9 that go with those pairs. If I know that opposite over adjacent is 1 over 1. I said opposite over adjacent. If I know that opposite over hypotenuse is 1 over square root of 2, I can rationalize it. It's the same from either angle because they're both 45. Reciprocals of all that stuff. You gotta review it. It is expected that you know this. Okay. Now, think about your performance in here so far. We literally have the entire room, everyone in the class at an A or a B. The reason that PreCalc gets the bad rap is because kids have to try. Look at this. It is expected that you know this before you even walk in the room. Think about, oh, you're going to start chapter 4. Good luck. How many of you have heard something like that? Okay. Is it because it was insanely difficult or because you weren't adequately prepared beforehand? It is not tough. If you know this, the next 3 weeks are actually kind of a joke. It's just graph this stuff on repeat mode. Okay? It's formulaic and it's graphing. What about fractions? Y'all know how to cut a pizza? Whether you can cut it straight or not is another matter. Okay? What if I said that this is 0 and this is 1? Now if I started chopping this thing up, could you tell me what portion of it, what fraction this is? If this is 1, what's this? No. Half. What's this? A fourth. What's that? To get from 0 to 1. The top is cut into thirds. That's 1/3, that's 2/3. Because you were supposed to learn radians in geometry. Pi over 2, pi over 3, pi over 4. Okay? Yes. Oh, this? No. What you absolutely have to know for tomorrow. That. We'll get the chart. We'll go through it tomorrow. But you have to know special right triangles and Pythagorean theorem. You have to. Okay? Tardies. Tardies and detentions. Yeah.